we're going to be talking about A/B testing. So the idea is this to just show you a little bit what A/B testing is, some of the jargon that usually is used around A/B testing, but it's mostly just a special version of a randomized control trial, or a more hyped version of a randomized control trial, for the most part in this case. Okay. So A/B testing is very popular right now, and basically what it does, it tests effect of small changes in products on an outcome of interest. So you can think about this, especially in web development, when the user would be exposed to a different version of the same website with just small changes. So they're not very noticeable in that sense. So the position of a banner, the color of a button, sort of things like that, okay? So the idea is that companies can quickly analyze and adapt their design and actually continue to test different features. And it's called A/B testing, basically, again, because you have sort of two different treatments and you're assigning people to either one or the other. And then you can have other A/B tests after that and things like that sort of concatenate this, this different sort of experiment. And you can do it very quickly because, again, especially in web development, you get a lot of users interacting with your website. So I first wanted to start just talking a little bit about the jargon that that you can hear usually in around A/B testing. So even though we're not going to specifically be looking at some of these things here, I think it's always important to sort of know what's going on and at least have the context in your mind of how you would implement it in the future, in that sense. So there's a lot of jargon around A/B testing, and a lot of names that are thrown up out there. So what does this all mean? So you might have heard the term conversions or regret, not in any other sense, but like in A/B testing sort of scenario. Also like bandits, and you might wonder what all of that is. So we're gonna try to clear some of these things up so you know how they fit sort of in the context of a randomized control trial. So conversions basically is your outcome of interest. So it's to cause a customer to take action. So that's like a marketing sort of a marketing sort of term. So the action that you make might vary depending on what your objective is. So for instance, if you're a big retailer, like, I don't know, Sephora, your action would be, for instance, to get a customer to buy something, to make a purchase online. For me, a professor, for instance, conversion would be to design a cool website so that people click more on the download that R script sort of button. Okay, so again, it depends on what the objective that you have is. Okay, regret on that, on the other hand, is basically the loss of conversions due to a low performing treatment. So in that case, you have to balance two things: the maximizing conversion and minimizing regret. Because a lot of the times when you're testing two different treatments, one of them is doing better than the other. So you're learning which one is doing better, but at the same time, when you're sending people to the one that's doing worse, you're probably losing conversions. So again, you want to, and basically you have more regret in that sense. So you want to balance these two things. You need to know which one is doing better. So you need that to maximize conversions, but at the same time, you want to minimize regret. And that's where bandits come in. So multi-arm bandits and contextual bandits the name comes from the machines at the casino that are called apparently one-arm bandits. I did not know this. So it's a learning moment for everyone. So basically, imagine that you're at a casino and you have a number of different machines. All of them have a different probability of you winning. For instance, this one has P1, P2, P3, right? And you don't know these probabilities. And you want to maximize your total payout, and you can only pull so many levers. So basically, you need to balance this idea of exploitation and exploration. So you want to pull a lot of these levers, but at the same time, once you learn that you have a higher probability of winning in one of them, you want to pull that one more times, right? And again, you only have a set number that you can pull. So you need to balance these two things. So here's where bandits come in. So multi-arm bandits, basically what it does is redirect users to more successful versions of the treatment. So at first, for instance, when you have no information, you might be sending people 50-50 to each of the treatments, right? So you're trying just to gain information. So you're exploring in that sense. But once that you get some information, you might want to redirect people from one treatment to the other one. So instead of sending them 50-50, you might send them 70-30 to the one that is doing better. Contextual bandits actually work a little bit similar in that sense, but also use prior information from the user to actually select an action. So they try to predict which treatment would be more appropriate for them based on certain characteristics. So they can see, for instance, whether they've been on the website before, or where they're coming from, or other characteristics that they might have saved and things like that. And they can use that to select an action that would be lead to more conversions. So now let's go into an actual example. So this is from a paper that is a very simple paper, but I thought it's actually very clear in the way that they think about the A/B testing. And they actually explain each of the different steps that they do very clearly. So I thought it would be a good example to show here. So this is basically the Montana University, the State University library website. So the problem that they had is that they thought that this interact button didn't, no pun intended, get much interactions. So they have a heat map, for instance, and you can see here that a lot of people go into the find category, which is not strange, or to the search bar, but there's very few action, very little action going on the interact button. So they were mainly thinking that the problem was the fact that the name wasn't very telling. So people did not know what was there in the interact section. And apparently there's like a lot of important things that people eventually did want to get to, but they didn't know that it was in that section. So what they did was they tested 4 different versions aside from the interact version, which is connect, learn, help, and services. So as you can see, basically they had the same website, they just changed the name of that button. And they got to this basically after just brainstorming some ideas and then actually conducted qualitative research around this. So they actually had a focus group with users to try to gauge which would be the best sort of names to test out, which is also an important aspect of A/B testing in that sense. Okay, so they had 5 treatments in total. You could think about interact as the control and all the others 4 at different treatments. And then we want to analyze results. And how do we analyze this result? This is actually very easy. Again, this is exactly the same as a randomized controlled trial. So we just want to basically compare outcomes by group in this sense. So Google Analytics actually has very cool features related to A/B testing. And you can actually put here the variations, for instance. So this is basically showing how many page views had each version of the website. And as you can see, they're mainly very well balanced. So there wasn't one treatment, for instance, that got substantially more views than the other ones, which is great. Because again, we're just doing traditional A/B testing here. We're not necessarily sending more people to one intervention. So we're not doing multi-arm bandit or contextual bandit or anything like that, okay? Very simple, straightforward. 5 different sort of levels of the treatment, and we're randomly allocating people as they come to one of these treatments. What Google Analytics also shows you is the workflow. So basically you can see how people move within your website. So in this case, for instance, you can see what the starting page is. The main one is the home page. And then you can see what the first interaction is. So basically this is the click-through rate. Then basically you can also look at the drop-off rate. So people that were here and then basically just left the website. So did not make a second interaction. just moved along, or people that were here and then went back, and we're kind of using those measures as outcomes in this sense. So if we compare click-through rates from the homepage, so this is basically interaction. Okay, so people go to the homepage and then they first, whether they click or not in one of those buttons. So as you can see, services is clearly the winner, and it gets the most click-through rates. Learn is doing the worst in this case, and the control group, which is like the status quo in this case, is basically stuck like in the middle. If we look at drop-off rates now, so this means that people that go to this button or this page and then they just leave the website, you can see that Interact actually has the highest drop-off rate. So maybe people go here and they're like, oh, I don't understand anything, whatever, and they leave. And Services has the lowest, and it's almost 0. So people go here and actually stay in the website. We also measure, they also measure homepage return rate. Basically means that people that were in the homepage went to this button and then probably did not find what they wanted and they went back. Okay, so they need to like search in another part of the website. And as you can see, Connect has the highest homepage return rate, which is not good. And Services, again, has the lowest. So by all this measure, it seems that Services is the one that's doing the best. And it, as they show there, it basically also, it's consistent to what they got from their focus groups. So again, it could have been perfectly possible, for instance, that you did not have... you did not get the same results for one specific button. So for instance, if you look at Learn did not do well in the click-through rate from the homepage, right? It's the one that did the worst. But also, once people got there, has one of the lowest drop-off rates, and the same thing with homepage return rates. Okay, so people don't really click there, but after they click there, they know where they're going. Okay, so if we want to compare Learn, for instance, with Connect, it's not very clear which one is better in that sense. So again, it depends on the objective function that you have in. Okay, now finally wrapping things up. Hopefully some of the takeaways that you had from this class is that randomized controlled trials are actually great. Remember that by design, we're buying us the independence assumption, basically. But they're not great for everything, okay? There's a lot of limitations. But we do get no systematic selection on observables or unobservables, which is the main advantage that RCTs have over other identification strategies. But also things can go wrong too, okay? So you have to think about attrition, you need to think about non-compliance. If you're trying to generalize to specific populations, external validity or generalization is a huge issue that, again, it's always better to tackle in the design phase than afterwards with ex post adjustments. So we're going to be looking at that also next week. But always check your assumptions also and look out for potential issues. So looking at, for instance, missing rates on your outcomes, imbalances in some key covariates. How many covariates are imbalanced? Should I need to stratify for this field experiment, for instance? All of those things are stuff that you need to think before actually you run any experiment. So unlike observational studies, which is what we're going to be looking at next week, you have to put a lot of work before you actually get the data with randomized controlled trials. So that is kind of like, I wouldn't say disadvantage, but you clearly cannot, there are things that you cannot fix ex post, okay? It's easier to think about them ex ante and basically design your RCT that is robust to certain things. So again, a lot of legwork comes before you actually get any data. Next class, we're going to be looking at observational studies. So we're moving away from experimental data I'm moving over to basically data that is already there, generated, and it is not actually, we're not able to manipulate beforehand. We're going to be talking about selection observables and how credible that assumption might be to a certain extent. And we're also going to be talking about the wonderful world of matching and everything that involves different ideas of matching. What does matching bias? What it doesn't bias? And basically when it's appropriate to use it and when it's not, and for what reasons. Okay, so it was great seeing all of you. I mean, not seeing, but talking to all of you. Take care, and I will be uploading the next video soon. Okay, reach out if you have any questions. I will be available all of next week, so even Monday or Tuesday, if you want to meet for office hours or any other meeting, I will be available. Okay, so have a great rest of the week, and see you, I guess, next class.